right, so you guys, we're going to be kind of flipping back and forth between our lesson notes that we've already done the first half on and the second part of it that I want to kind of show you digitally. So this screen that you're looking at right now goes with this page right here. It's a third page into the notes. Okay, and you might be able to type this in and play around with what I've got going on. I'm going to just kind of be looking through, going through a digital version of answering these questions. So this is where you can follow along with what I've got going on the screen. Okay, so the first one is an example given side lengths 1, 1, 1. Are you able to build a triangle with those side lengths or not? And then classify the triangle based on the sides. Is it a scalene, an isosceles, or equilateral? Okay, so let me go back to this. Okay, so I'm going to go ahead and change these sides 1, 1, 1. And I'm going to blow this up so we can really see. Let's see, did I go too big? That's probably good. All right, so these are side lengths 1, 1, 1. You know what, I went a little hair too big. Okay, so please bear with me with them kind of troubleshooting with you. So this does make a triangle. There is a way to perfectly line up these endpoints. They're called vertices, so that the three sides form an enclosed triangle. So you're going to write, well, it's already written on your paper, yes, and you know this is equilateral because all three sides are the same length. Okay, now the next one. The next one is, can a triangle be formed with side lengths 2, 2, 3? So I've got 2, 2, and I need to change this one to 3. Okay, let me blow this up so we can really get in there a bit. Okay, so are we able to enclose this triangle? If I play around with it a little bit, almost there. Okay, so does this form a triangle? Yes, it does. So you're going to put the word yes in the 2, 2, 3 box, and then sides 2, 2, 3, 2 of them are equal. That is called an isosceles triangle. Okay, so you are writing yes, isosceles triangle in this row. Okay, the next one we're going to do is this 1, 2, 3. All right, next slide. Can a triangle be formed with side lengths 1, 2, 3? So let's make this one a 3. So I've got side lengths 1, 2, 3. Let me blow this thing up. All right, so this is side length 3. It already formed it for me. Okay, is there any way we can form an enclosed triangle with this? I hope you're seeing no. There's no way to form this as an enclosed triangle. So your answer in that row is going to be no, and you're not going to answer this because it doesn't form a triangle. Okay? All right, we're going to do the rest of them, 2, 3, 4, 1, 3, 4, 4, 5, 7, and 2, 5, 7. Let me get back to my digital version here. 2, 3, 4. 2, 3, 4. Okay, so I've got side length 2, 3, 4. That's what these are, 2, 3, and 4. Let me blow this up, scooch it over. Yes, I can finagle these to be perfectly lined up with an enclosed triangle. So you're going to write yes. 2, 3, 4, they're all different. So you're answering that row with scalene triangle. Okay. The next one, 1, 3, 4. 1, 3. Doesn't matter which one you let be 1 and which one you let be 3, which one you let be 4. That doesn't matter. Let me blow this up. What do you think? This kind of just closes down on itself, doesn't it? Where did that one line go? There it is. All right, so you guys, it's super close, but there's no way that that's ever gonna line up. And I just lost it again. There's no way this is ever gonna line up on each other. It gets very close, but it's pretty much gonna collapse down on itself. Okay, there's no way to form an enclosed triangle with side lengths 4, 3, 1. So you're going to say no in this row, and then you're going to have like a not filled out last column or put a line in it or not applicable or something like that. Okay, this guy, 4, 5, 7. 4, 5, and whoops, too big. 7. Let me blow this thing up a bit. Okay, so what do you think about this one? We can play with this a little while and get that to be an enclosed triangle. This is off a tad, but I can continue. There we go. Okay, it's an enclosed triangle. So 4, 5, 7, your answer is yes. And it's a scalene because those are all different side lengths. Okay, 2, 5, 7. 2, 5, 7. It's going to be kind of way over here. Super obtuse, isn't it? Let's see, where is it? Oh, can we make this? Can we make this happen? Oh, it's close. Super obtuse again. Let's see. Come on now. It gets really hard to move when it gets down this. Let me bring that up a little bit. Okay, it's close. It's close. It's close. Those don't quite overlap. Okay, again, they're close. Okay, let's zoom in so we can see if that's together or not. No, that is not together. Thanks for bearing with me while I'm trying to muddle through this to show you guys. Come on, move down. No, don't move that way. Ooh, you can really see it's nowhere near being together. Okay, see, look at that. If I blow it up and blow it up and blow it up, it's being really finicky. It's not wanting to. So there's no way that this, come on. Okay, is this even a triangle anymore, right? Okay, holy smokes. There is no way that this is ever gonna, I keep zooming in and zooming in, there's no way this is gonna ever work out. Okay, so your answer is no on 2, 5, 7. And it is you're just gonna have like a dash or a blank box at the end because it doesn't form a triangle. All right, use the triangles we made on the previous slides to make a conjecture. What do you notice about the relationship between the sum total of the shortest and medium side lengths of the triangle compared to the longest side length? All right, are you noticing anything? Okay, here is what I want you to write in your notes. Okay, so we're making a conjecture, which is a rule. Okay, the sum of the shortest and the medium sides of a triangle compared to the longest side. If the smallest sized and middle sized sides are added together and the sum is greater than the largest side, then the three sides can form a triangle. Okay, that is key. And I'm going to go back to what we just did digitally and show you what this means in a moment. If the smallest sized and middle sized sides are added together and the sum is greater than the largest side, then the three sides can form a triangle. Okay, so let me go back to the previous page. Okay, so let's take the two smallest sides, the smallest and the medium. They're all ones, so we're going to take two of them. Add them together, 2. If that number 2 is bigger than the third side, your answer is yes. Okay, let's take the two smallest. Add them together, 4. Is that bigger than 3? Yes, it forms a triangle. Ooh, look at this one. Take the two smallest, 1 and 2, add them together. 3. Is 3 bigger than 3? No. Remember that one came close, but we could never quite get it. It kind of collapsed in on itself. Okay, this guy, two smallest sides, 2 and 3 added together, 5. Is that bigger than 4? Yep, it forms a triangle. 1 and 3? 1 and 3 add to 4, not bigger than 4. It came close, but it doesn't quite make that triangle. 4 plus 5 is 9. It's bigger than 7. Yep, it makes that triangle. 2 plus 5 is 7. Not bigger than 7. No. Okay, so that's the rule behind what you just saw happening. Okay, let me get back to my Desmos slides here. I think we're just kind of walking through the notes now. Okay, so this is on your notes here. Okay, so turn a page. Okay, using this, okay, we're going to add together these two side lengths and it must be bigger than this. And we're going to add together these two side lengths and it must be bigger than this. And then the only one left to compare are these two side lengths added together. It must be bigger than this length. Okay, that is the triangle inequality theorem. They're saying that C is the longest side. Okay, now it's really important to understand you don't need to check all three. There are two inequalities up here that are understood within the third one. Okay, if C is the longest, sorry, this is the only one you really need to check. Doesn't it make sense that you need to add the two smaller ones together and they need to be bigger than the longest? Okay, if you add the smallest and the longest, wouldn't that be bigger than the middle one? Okay, so that one is included inside that one. Same with this. If you added the two biggest, isn't that understood? It's going to be bigger than the smallest. Okay, so you really only need to check this one. Okay, so let's get on to back to our plain old notes. We're going to answer these questions right here, and that will conclude our lesson. Okay, it says determine if it is possible to form a triangle with the given side lengths. Justify your answer using the triangle inequality theorem. All right, so we're going to take the two smallest, add them together. 7. Is 7 bigger than 8? No. And our justify is going to be since 3 plus 4 is not greater than, that's what that means. 3 plus 4 is not greater than 8. Okay, so we're just using the two smallest sides. Is it bigger than 8? If it is, you leave it. If it's not, you just draw a slash through it. Okay, the two smallest, be careful. 12, 18, 16. Ooh, they didn't give them to you in order. So we're going to add these two together. Is that bigger than 18? Yes. Since 12 plus 16 is bigger than 18. Okay, this guy. The two smallest, 15 and 20. Added together, is that bigger than 25? Yes. Since 15 plus 20 is bigger than 25. Okay, this guy, the two smallest, 7 and 8. 15 is bigger than 9, so yes, since 7 plus 8 is bigger than 9. Okay, this guy, 14 plus 2 is 16. Is that bigger than 15 and a half? Yes, since 14 plus 2 or 2 plus 14, doesn't matter, is greater than 15 and a half. This guy, the two smallest, 5 and 4, that would be 9. It's bigger than 6 and a third, so yes, since 5 plus 4 is bigger than 6 and a third. Okay, so that's all you're doing for those. Okay, now, here come tricky questions. Okay, the next handful we're going to do, 2 little sections. These are tricky. All right, determine the least possible measure, the third side of a triangle with given side lengths if the missing measure is a whole number. Show your reasoning. Okay, so we're looking for the smallest. We're looking for what this needs to be if you add 12 of it and 12 to it, and it has to be bigger than 15. Okay, so let's think about that. If I put a 3 in there, I'm equal. So I need to go one more than that. So 4 meters. Let's think about that. 4 plus 12 is 16. That's bigger than 15. Couldn't I put 10 in here? That's 22. Couldn't I put 100 in here? Yes. But the least possible is 4. Okay, so this guy, we're looking for the smallest plus the middle, has to be greater than 10. Okay, let's think of some possible numbers. 10 would work. 5 works. Ooh, does 2 work? 2 is equal. So we need to go one step larger than that. So 3 inches. 3 inches is the smallest. There are many that we could put in here, but 3 inches is the smallest. Okay, let's look at this one. Question mark plus 6 is greater than 6. Okay, it obviously can't be 0. If I put 0 in there, there's no third side, right? And 6 is greater than 6? No. Okay, but if we put a 1 in there, ooh, that works. If I put a 5 in there, that works. If I put a 10 in there, that works. But the smallest, the least, is 1 centimeter. Okay, and then there's this last guy in the corner here. Question mark for the smallest plus the middle size, 11, has to be bigger than 13. All right, well, 10 works, 8 works, 5 works. Keep going smaller. 4 works. 3 works. Does 2 work? Ooh. 2 plus 11 is equal to 13, so we need 3 feet is the least. Okay. Got one more little part. We've got to look at the greatest. So on the next page, we're looking for the greatest possible measure of the third side given 2. Okay, so this time we're looking at 12 plus 15 is greater than question mark. We're looking for the greatest. The greatest is always on this side right here. Okay, so if we add these together, that's 27. Well, 27 is bigger than 1. 27 is bigger than 5. 27 is bigger than 10. Okay, I'm looking for the biggest. 27 is greater than 26. 26 meters. Okay, this guy right here, 8 plus 10 is greater than question mark. 18 is greater than 17. It's greater than a lot of numbers. It's greater than 2, it's greater than 5. Okay, but the biggest number we could put in there is 17. We couldn't put 20 in here. 18 is bigger than 20. 17 is the biggest. Okay, this guy, 6 plus 6 is greater than question mark. Okay, this would be 12. 12 is greater than 11 centimeters. Okay, 12 is greater than a bunch of numbers, but we want the largest. Okay, and then this last one, 11 plus 13 is greater than question mark. Okay, well this would be 24. That's 24. 24 has to be bigger than something. Well, 24 is bigger than 20. 24 is bigger than 21. 24 is bigger than 22. 24 is bigger than 23. 24 is bigger than 24. Ooh, I found my cutoff. 23 feet is my answer. All right, this lesson is very important to understand, okay? All right, thanks guys.